I'm already recording. Go ahead.
Okay,
Hi.
so this is our truss bridge design. I'm Sam.
I'm Kyle. And I am the 441st Jacob on PLTW.
Okay, so for our design brief, we had to design a bridge at a 24-meter elevation. That's no higher than 8.5 meters from the riverbed to take into consideration power lines, any kind of safety measures that need to be taken for that. And the goal ultimately was to design a cost-efficient bridge, which was under the $300,000 cap. It had to be structurally stable without using an exorbitant amount of resources, so cost efficiency and such. And there was, in regards to the resources, we had a maximum of 50 joints and 50 joints and 120 members, I believe. Yeah.
So, here are our first three designs. You can see that we went from everything from very thick to slightly thick to thin. So each one had, next slide. Each one had a problem with it where we would constantly either run into cost issues, the way it looked, the amount of resources. And like stability was, I think stability was our best for all three of them. So we went with Model 3, and here's what it looks like originally. Model 3 cost over the mark of $300,000, and its compression and tension ratios were 0.6 and 0.2. And our goal was to make it cheap as possible without killing the driver. So, after slight modifications, making a couple of the bits hollow and changing up what we were using, we were able to get it under 250,000.
Okay, so it's really wordy, but this is a research summary. We didn't really incorporate it, I suppose. So in regards to the first question, the type and direction of stress applied, how does it affect the selection of our material and the cross-sectional areas? So basically, depending on the stress type and the direction, the material needs to be stronger in order to resist the tendency that it would have to stretch or bend wherever there would be more tension or wherever there would be more pressure applied or force. The forces of compression and tension, they because they are opposite forces, they would work together to make a stronger bridge by canceling each other out, and it would sort of create a sense of equilibrium and a decision matrix that Jacob explained. It's used obviously to come to a consensus, so you weigh out your different options, and so in this case it would be stability, aesthetics, cost, and resources. And so basically it helped us narrow down to the final decision that we came to. And like I previously said, a consensus is an agreement. So teams use consensus to make a decision by making compromises and coming to an ultimate decision. And the properties and types of materials, they affect the solution to a design problem because different properties of materials, they have an impact on the cost of a project. So in our case, we had a $300,000 budget. So the design that we had for the bridge, it had to take into consideration the properties of the materials that we use in order to reach that budget and go under it.
And I believe as of now we have the cheapest bridge in the classroom. So, not to brag. Okay, a bit to brag, but yeah. So here are the different members, 21. So 21 members, each one having an extremely vital role in making sure that we had each one with their strengths instead of their weaknesses. Some able to compress, some able to take on tension. So the members were changed to make it a little bit more cost effective. The look of it, we're going based off of traditional railroad bridges, mostly because they were able to carry tons of weight for an extended amount of time, and it was simple. We also, our main thing was for it to be cheap. We wanted to make sure that it wasn't over $1 million, nor we didn't want it to go over our price range of $300,000. Literally our only references, and I think that one did. Oh, and
Yeah.
here are the other bridges that we were like basing ours off of.
That concludes our presentation, except for
But hey.
our video.
Yeah. There's let me just yeah. So as you can see, here's our bridge. It's got a truck going over it. And we can even see the first person perspective of the driver, so it's basically heart attack simulator.
And yeah, that is our bridge. We
Alright,
live
just-
just
Can you guys stop recording? I want to